All right, so one of the other things that you need to be able to do in this section, other than expanding and condensing logs, which is what we talked about prior to break, is you need to be able to evaluate logs without using a calculator. And so you can expect to see this on quizzes, tests, and your final, because it is not something that you can just enter in your calculator and solve. You actually have to know the steps. Now, the steps aren't very difficult, and you can do it without using a calculator, usually. Okay, sometimes you do need to use a calculator, but for a couple of these types of problems, you can just do them by hand. And so I want to make sure that you have real thorough notes so that you can do this on your own when you get the opportunity. All right, so the first thing when you evaluate these logs is you need to expand them out as you would if you were just expanding. So step one, you're going to expand the logs. Okay, so the first step on this is if we take this whole log, anytime you have a factor in the numerator of a fraction inside of a log, when we expand it out and write it as a distinct log, it'll be a positive log. Any factors that reside in the denominator of a fraction within a log will always have a negative in front of them. So as we expand this out, each individual log will have the same base. So log base 3 of, our first factor is a, so we write a cubed. And since the base a is in the numerator, we're going to leave this a positive log, so we don't put a negative in front of it. Go to the next factor. The next factor is a b, so we're going to write log base 3 of b. b is also in the numerator of this fraction, so we're going to have a positive sign in front of that as well. And now we move to the denominator. So our next factor is 3, so log base 3 of 3. Since this 3 is in the denominator, we're going to put a negative in front of that log. And then finally, we have this factor of c. So log base 3 of c squared. Again, we can keep our powers intact. But since this factor of c is in the denominator, we're going to put a negative in front of that log. So right here is just the expansion of this log. And now we're going to expand these logs completely. Okay, so what I did there was just the initial step for expanding the logs. What you can also do is anytime you have a power inside your log, you can move that power into a coefficient in front of the log. So we'll move that power of 3 out front. We'll move this power of 2 out front. And so this would be the expanded log. Okay, what you'll then do as your final step is to simplify where necessary. And all that requires is if you have any expressions that can be reduced or changed or evaluated, you want to do that. So we leave 3 log base 3 of a. There's nothing to change about that. Plus log base 3 of b. Nothing to change about that. Now, here we do have something we can change. Anytime you have something log base a of a, think about what the exponential form of this would be. Okay, the exponential form of this would be a to what power is equal to a. So what is the value of log a of a? Log base a of a. What would be the power? A to what power is equal to a? 1. Anytime you have a log base where the base and the number inside the log are exactly the same, its value is 1. So right here we have log base 3 of 3. So this has a value of 1. So we simply replace that with a 1. And then the minus 2 log base 3 of c. Doesn't simplify at all. And so the only simplification here was this log base 3 of 3. But that would be our evaluated form. And now, the final step for this is to, and you can kind of combine these steps 2 and 3, is to evaluate. And so with our final step right here, what we can do is we can go back in and everywhere that a log has a specific value, we'll replace. So log 3 of a has a value of 2. So we get 3 times 2. Plus log 3 of b has a value of 5. So we replace this with a 5. Minus a 1. Minus 2 times log base 3 of c has a value of 3. So now we can evaluate this. 3 times 2 is 6, plus 5 minus 1 minus 6. The 6 and the negative 6 cancel. 5 minus 1 leaves us with an overall answer of 4.